Hello everyone. Today we are going to start Lecture 5, Endogenous Growth Theory, which corresponds to Chapter 9 of Mankey's textbook. The title is Population Growth and Technological Progress. In the previous lecture, we've so far focused on the Solow model. So today, we will discuss its limitations and we will study model that try to explain technological progress endogenously from within the model itself. Let's first think about what we learned from the Solow model. The Solow model teaches us several important lessons. First of all, capital accumulation is the key driver of economic growth. However, we learned that in the long run, once the economy reaches its steady state, growth in output per worker is possible only through technological progress. So, in the Solow framework, accumulating capital alone cannot sustain growth forever. Only technology can keep the economy growing in the long run. Okay, let's look at the limitations of the Solow model. The first, it does not tell us why people save what they save. The saving rate S is just assumed to be given, meaning that it is an exogenous variable. So it does not come from household optimization problem. This is just assumption. And second, it does not explain how technological progress actually happens. It just assumes that some exogenous force, for example, innovation, education, or government policy, increase productivity at a constant rate. So we can say that the Solow model is very powerful, but it incomplete. So naturally, it raises a question. Where does technology come from? So that question is exactly what endogenous growth theory tries to answer. A major strand of modern macroeconomic research tries to endogenize technological progress. In other words, technology is not something that just falls from the sky. It is something that economic agents intentionally produce. So this line of research is called endogenous growth theory. So in these lectures, we will cover these the three major models. Okay, the first one is the AK model. AK model is the simplest model where growth is sustained by constant returns to capital. And second one is the two-sector model, which drives the economy into production and research sectors. The third one is the Lomas model. The Lomas model is the most influential model that explain how ideas lead to the sustained growth. Lastly, later we will also study related research called optimal growth theory, which endogenize the saving rate. But for now, our focus is on technological progress. Okay, let's begin with the AK model. In the Solow model, growth eventually stops because of diminishing return to capital. So let's look at this figure to understand why growth eventually stops in the Solow model. So here, red line shows investment as times F. It flattens out as K increase because the production function is diminishing returns to capital. The blue straight line shows depreciation, delta K, which increase proportionally with K. Okay, let's look at this intersection point. This is the steady state, K star. So as we know, at this point, investment exactly equals depreciation. So when K is below K star, investment exceed depreciation, so capital accumulate and K rise. However, when K is above K star, the steady state level of capital, depreciation exceed investment. So capital decline and the capital falls back. So eventually, the economy settles at K star. At this steady state, capital per worker stops changing. So output per worker also stops growing. Unless there is technological progress. So that's why in the Solow model, growth slows down and stops in the long run. As capital accumulate, uh, uh, diminishing returns flattens the investment curve and the economy naturally converges to K star. Okay? So if we want permanent growth without assuming exogenous technology, we must remove the diminishing return diminishing return to capital. So the AK model does exactly this point. Okay, this production function is defined as output is equals to A times K. So here K is the only input capital and A is a constant productivity parameter. So the marginal product of capital is simply A. So it is constant and it has a positive value and it is not diminishing. So investment is given by S times Y. Depreciation is given by delta K. So the law of motion for capital is uh, given the law of motion for capital is like this. Changes in capital is equals to the difference between investment and depreciation. Okay? So we can compute the growth rate of capital and output. So by substituting y to a k, so we can get this equation. So this first equation indicates the law of motion for capital. And using this equation, we can get the growth rate of capital. Since output and capital grows at the same rate, this is also growth rate of output. So if SA is larger than delta, then the growth rate of capital has always a positive value, which means that the economy grows forever. So it means that for any level of capital, the growth rate of capital is larger than 0. It implies that investment can be an engine of economic growth. Okay. However, all these three parameters, S, A, and delta, are exogenous variable. So it implies that the AK model is very simple model. So it does not explain everything, but it can be a good start point uh, the thinking about how growth can come from inside the economy. Okay. Now you might ask, does capital really have non-diminishing returns? Actually, it depends on what we mean by capital. So we define capital, if we define capital narrowly, only machine, buildings, or equipment, then the answer for this question is yes. Diminishing returns make sense. But if we think more broadly, including knowledge or human capital as part of capital, then constant returns to capital become plausible. So, in this case, the AK model provides a reasonable description of how economy can sustain growth. So, the AK model assumes the constant return to capital. So, it leads to sustained growth. Actually, this insight that knowledge behaves differently from physical capital lead us naturally to the next model, the two-sector model. Okay, let me introduce the two-sector model. This model tries to explain how technological progress occurs. So the basic idea of this model is that there are two sectors in the economy. The first, the production sector. The production sector means that manufacturing firms produce goods using capital and labor. Second one is research sectors. The research sectors means that university or research lab produce knowledge which improve labor productivity in the production sectors. Okay. Here, fraction of labor U is indicate the share of labor in research sector. And the remaining 1 minus U works in production sectors. So manufacturing production function is defined as a function of K and labor is defined as 1 minus U times effective workers. Okay. And the research production function is defined as like this. The changes in labor productivity is a product of the function G and the initial level of labor productivity. Okay, this equation means that the growth rate of labor productivity is defined as a function G. The function G depends on a share of labor in the research sector. Okay, so meaning that the growth rate of labor productivity depends on of the share of labor in research sector U. Okay, and typically capital accumulation is followed by this equation. Changes in capital is equals to the difference between investment and depreciation. Okay. Okay, let me note that the increase in labor productivity is proportional to existing level of labor productivity. Okay, so this means that knowledge builds on itself, which implies that knowledge is non-trivial, non-rival goods. Okay, let me briefly explain the difference between rival goods and non-rival goods. Rival good is one that cannot be used by more than one person at the same time. So example of rival good is a food, a car, or a machine, etc. So the capital-like equipment is typically rival goods. However, a non-rival good can be used by many people simultaneously without being used up. So the example of this non-rival good is knowledge, idea, or software, or a mathematical formula. So the knowledge is a typical example of non-rival goods, and so that's why it behaves differently from physical capital. So just like in the AK model, in the two-sector model, the return to knowledge do not diminish. So which means that the growth rate of labor efficiency is always positive. That's why research becomes an engine of long-run growth. Okay, uh, I will show the main implication mathematically. So in the steady state, the growth rate of output per workers equals the growth rate of the labor productivity. And under the assumption in the previous slide, the growth rate of labor productivity follows the function G. And function G depends on a share of labor in the research sector. So, this the equation means that the growth rate of output per workers equals to function G, which depends on a share of workers in research sectors. So the long-run growth rate depends on how much labor goes into research, not on uh, the manufacturing sectors. So in this two-sector model, here S affect level of output, but here U can affect both the level and growth rate of output. So this is a key difference from the solo model. Okay. Okay. In this simple version of two-sector model, here U is treated as exogenous variable. But in more advanced model, household or government choose U optimally by solving the household optimization problem or uh, government's optimal problem. Okay. Let's think about the trade-off. So if we send more workers to research sector, the economy invents more idea and future income will grow faster. But cost of it is that fewer workers remains in production sector today, so current output should falls. It implies that there's a tension between current consumption and future growth. Okay? So the different country might face different trade-off that depends on their initial level of the the knowledge or how productive their research sector is. The meaning, the functional form of G. Okay? So each country have different functional form of G and different level of labor productivity, which means that the trade-off should be different across countries. Okay, so that can help explain why some countries invest heavily in R&D and grow fast, while others do not. Okay. Okay, let's look at some empirical facts that motivate modern endogenous growth model. Much of R&D is done by private firms, not government. Firms do research because they expect future profit. So firms profit from research mainly through patent, which allow them to enjoy temporary monopoly profit. So they can be the first mover in their market. But innovation also create uh, the positive externalities. Once a new technology is discovered, it can help others innovate more cheaply. Because of these externalities, the private R&D efforts alone are not enough to maximize social welfare. Okay, so this leads to a policy question. Is the private sector doing enough research? Uh, uh, is the private sector doing enough research? So evidence suggests that it is probably not. Actually, knowledge creation generates positive spillover, so private firms underinvest compared to the social optimum level. On the other hand, there is also duplication. Several firms race to invent the same things, which waste resources. The empirical estimates suggest that the social return to R&D is around 40% per year, which is far higher than the private returns. So many economists argue that governments should encourage R&D, for example, through subsidy and tax credits, research grant, or patent protection. So this is one of the central policy implications of endogenous growth theory. So market alone may not produce the socially optimal amount of innovation. Okay, let me summarize what we've covered so far. The AK model shows how constant return to capital can sustain growth, and the two-sector model introduced the idea that the knowledge creations drives growth. And we have seen why R&D policy is crucial for sustaining innovation. Okay, And the next class, we are going to study the Lohmer model, which combine these insight into a single framework. So the Lohmer model can explain how ideas lead to sustained economic growth. Okay, let me stop here and thank you for listening to my lectures.